What's up, guys, and welcome back to Atomic Talk. I'm Sam, and today we're going to be interviewing Professor Rogoff, nuclear chemist and PhD from the University of Maricosta, about the interesting element berkelium. Professor, thanks for coming on.
Of course, I love sharing about the work and elements that my work is centered around.
That's great to hear. First question to start with is how this element was discovered.
Yeah, so this element was discovered in 1949 at UC Berkeley, surprisingly, and scientists bombarded americium with alpha particles, and after a lot of trial and error, ended up with a new element. But, it's important to understand that this process was extremely experimental, and, the scientists had to analyze the results, super fast, because berkelium is a very unstable element.
Yeah, nice. Now tell us more about its very short half-life.
Yeah, so some of berkelium's isotopes break down super quickly in just a few hours. And the layout this is kind of a funny story, but the layout at UC Berkeley during this time saw the chemistry and the radiation labs in different buildings across campus. And student traffic during the day made it very hard to travel between these buildings just because of students walking to class. So because of this, since the element was decaying so quickly, scientists decided to conduct these experiments during night so that they could rush the element across campus without students walking to class so they could test the element before it lost its radioactivity.
Wow, that's crazy. I can't even imagine hauling radioactive material through empty streets at midnight just to beat the clock.
Yeah, exactly. It just shows how fragile but also cool the whole process was. They were literally racing against time. That's what makes this kind of research so intense, because since the element only exists for a short while, you have to be ready the moment it appears.
It's wild how quickly berkelium breaks down. With such a short half-life, is it even useful for anything?
Yeah, it actually is. Even though it doesn't last very long, it plays a really important role specifically in research. Scientists have used berkelium to help synthesize even heavier elements like tennessine specifically, which sits out in the super heavy region of the periodic table. These elements don't exist naturally, so creating them helps us understand the limits of atomic structure and stability.
Wait, so berkelium is mostly used for research purposes, right?
Yeah, so berkelium isn't really practical for everyday use, obviously, but in the lab it teaches us new things about the boundaries of chemistry and nuclear science.
And politically or ethically, any controversies around it?
No, there's no major controversy about berkelium itself, but it has been closely tied to nuclear research, especially during the Cold War, actually. And it was used in classified experiments and was produced at national labs that had also developed other nuclear weapons. And what it basically does, or its key roles, is it is used for the synthesis of heavier elements like tennessine and californium. And these are studied for potential uses in nuclear reactors and also advanced technology. So while berkelium isn't the most important element and it's not specifically weaponized or used by nations in wars, it still plays a major role and has some military applications.
Got it. Well, Professor Rogoff, thank you so much for hanging out with us and explaining berkelium to us.
Of course, anytime, and always feel free to reach out with questions. I love talking about the work that I love so much.
Perfect. All right, thank you all so much for listening, and this is Sam from Atomic Talk.